Today's lesson is on radical and rational exponents. So first we want to talk about what a radical is. A radical is an expression that uses the square root, cube root, fourth root, or higher symbol. So some examples of that are this square root symbol here, or the cube root symbol, the fourth root symbol, or the fifth root symbol, and it keeps getting higher. That's probably about as much as we'll cover today. Parts of the radical, we have this little number in here, like the 3 and the 4 and the 5, or in the case on to the right, we have n. That little number we call the index. The number in the radical, or under it, is called the radicand. The nth root of a means the value when raised to the nth exponent equals a. Now I know that's really confusing with letters like that, so let's go ahead and do an example. So the cube root of 8, this little 3 says it's the cube root of 8, is pronounced cube root because of the little 3, it's a cube. And it means the value that when cubed equals 8. So we're thinking what value cubed gets me 8. Okay, that's what the cube root of 8 means. What value, when I cube it, would get me the inside? Well, one way of thinking about that is taking 8 and breaking it up. So we have 2 times 2 times 2, so therefore 2 cubed is 8. So when we have the cube root of 8, that equals 2. So that's what a radical symbol is. Now we're going to need to memorize a lot of the facts of perfect squares, perfect cubes, perfect fourths, and perfect fifths. So I'm going to make a list of those for you so that you can start memorizing them. So the first one says 1 squared is 1. Therefore, the square root of 1 is 1. Now we call this a square root. The little index, the number in the index, is a 2. We don't have to write it because we use square roots so much that if there's no little index there, it's an implied 2. We even say it. We say square root. Square, that's 2, okay? So 2 squared is 4, so the square root of 4 is 2. 3 squared is 9, so the square root of 9 is 3. 4 squared is 16, so the square root of 16 is 4. I'm going to go ahead and fill out the rest of these. You can just pause your video and fill them in. So as we get into perfect cubes and then the perfect fifths, you notice that the numbers get really, really large really quick. For example, 3 to the 5th is 243 because 3 times 3 times 3 times 3 times 3, 5 times, is 243. Therefore, the 5th root of 243 is 3. So these numbers get really large. Let's scroll down and do the bottom half. So when you're doing these, please be careful of the index. Some of these numbers repeat. For example, 5 to the 4 is 625, but so is 25 squared. So when you're talking about the 4th root of 625 or the square root of 625, you would get different numbers. So just be careful there. Same for 256 and 81 as well. 16 and 1 are even higher up there. It's off my screen though. So just be careful as they do come up more than once, and not just in the perfect fourths, but in other numbers as well. So now I want you to evaluate the following radicals. The square root of 49 is 7. And the reason that's 7 is because 7 times itself 7, the index says 2 times, there's an invisible 2 there, is 49. So the cube root of 125, what number multiplies by itself 3 times to get you 125? The answer there is 5. Be careful on this one. The 4th root of 16, what number multiplies by itself 4 times to get you 16? A lot of students are hasty and say 4. 4 times 4 is 16, therefore the square root of 16 is 4. But that's not what we're asking. We're asking about the 4th root. So it turns out that 2 times 2 times 2 times 2, 4 times is 16. So therefore, the answer is 2. Okay, the 5th root of 32, what number multiplies by itself 5 times to get you 32. If you're having a hard time memorizing these from the previous page, or you just forgot one, you could use this factor tree and break it up to its prime factors, and then you'll see that 2 multiplied by itself 5 times gets you 32, which is exactly what you were looking for. So this one's a little bit tricky. We have the square root of 1 over 81. So what we're going to do here is, what number multiplied by itself gets you 1 over 81? Well, you know 9 times 9 is 81, correct? But this is a fraction, so let's try 1/9. 1/9 times 1/9 is 1 over 81, so the answer here is a ninth. Same thing here, we know the cube root of 64 is 4, because 4 times 4 is 16 times another 4 is 64. So if we have 1 over 64, let's try 1/4. 1/4 times 1/4 times 1/4 is 1/64. Therefore, the cube root of 1/64 is a fourth. Next, let's talk about negative radicands with an even and odd index. So if we are going to consider the square root of negative 16, so what number multiplies by itself, the index is 2, times to get 16? Well, some students might call out 4. Let's try 4. 4 times 4 is positive 16, and we need a negative. Okay, so that's not going to work. Well, what happens if we have negative 4 times itself negative 4? Well, that also gives me 16, positive 16. Wait, I need a negative 16. And then some students will say, well, I know, let's just use one of each. Well, in radicals, you need to multiply the same number, the number of the index, that's how many times, to get the radicand. So I can't take a 4 and a negative 4 because that's not the same number. So, we've tried our best. We've tried the negatives in any such way. Neither of them work to make negative 16. So the answer here is there is not a real answer to this. It's just not real, or it doesn't evaluate to a real number. So on the next one, we have the cube root of negative 27. Well, let's break down 27. 27 is 3 times 9. Okay, so 3 might be the solution. Let's try 3 times itself 3 times. Well, that again gets me positive, and I need negative. Let's try negative 3. Again, the number of index 3 times. Negative 3 times negative 3 is positive 9. And positive 9 times negative 3 is, we got it. It is negative 27. All right, so this one has an answer. So the cube root of negative 27 is negative 3, but the square root of negative 16 doesn't have an answer. So why is there a solution to the cube root of a negative, but there isn't a real solution to the square root of a negative? Well, the answer is this. If you take the even root of a negative, there is no real solution. If you take the odd root of a negative, then the solution is just a negative number. And the reason this happens is because when you have even copies of negative, like let's say you have 2 negatives, well, that multiplies to be a positive. What if you have 4 negatives? Well, that multiplies to a positive. When you have even number of negatives, you only get positive numbers, therefore you can't take the even root of a negative. But if you have odd numbers, like let's say 3, negative times a negative times a negative, well, that's still a negative. Or if I had 5 negatives multiplied, that gets me negative as well. So therefore you can take the odd root of a negative, but you can't take the even root of a negative. Let's practice that. So the square root of negative 49. Square, that's an even root, so therefore is going to have a not real answer. There's no real solution there. The next one is the cube root. Well, 3 is odd, and because 3 is odd, we know our answer is just negative. So what is the cube root of 64? Well, that's 4. So negative 4 times negative 4 times negative 4 does equal negative 64. All right, the next one, the index here is 4. That's even. Can I take the even root of a negative radicand? No, so the answer is just not real. All right, so this next one is a little bit tricky. And the reason it's a little bit tricky is because you have to do the inside first here. You have to take -2 and raise it to the 4th power before you can do the even root. Sometimes students will look at the even index and just say, oh, not real. But because there's a 4th power in there, we actually have to work it out. So -2 times itself 4 times gets me positive 16. And now, with an even root of a positive number, the 4th root of 16 is a real number 2. So you can't be too hasty here, just saying if it's an even root and there's a negative on the inside, then it's going to be not real. You have to evaluate any exponents. The next one, my 5 is odd. So because it's odd and there's no evaluating to be done in the inside, I just know my answer is negative. The 5th root of 32 is -2. Again, don't be hasty here. This is odd, right? But we need to multiply it out first. So if I have -3 5 times, because I have an odd number of negatives, my answer in the inside of the radicand will just be negative. 3 to the 5th is 243. So we have the 5th root of -243. Now, this is odd, so is it allowed to be negative? Sure it is. And then my answer is -3. Now some radicals do not simplify quite as nicely as these do. We will learn how to reduce more radicals in the next lesson, but all the radicals we're going to be doing today work out fairly nicely to whole numbers, positive or negative integers.